Europe is warmer than it should be. At the same latitude, parts of Canada freeze much harder. So why doesn't London feel like northern Canada? It's not luck. It's not just geography. It's an ocean current, and scientists are worried it may be slowing down. If it stops, it won't just affect Europe. It could disrupt weather, agriculture, sea levels, and entire economies. Today, we're breaking down what this ocean system does, why it matters, and what could happen if it weakens or collapses. Because beneath the surface of the Atlantic, a planetary system is constantly in motion. Imagine the Atlantic Ocean as a giant conveyor belt. Warm water near the equator absorbs heat from the sun. That warm water travels north. When it reaches colder regions near Greenland, it cools. Cold water is heavier, so it sinks. That sinking pulls more warm water north, and the cycle continues. Slowly, over decades, but constantly. This system is called the Atlantic Meridional Overturning Circulation. You don't need to remember the name, just remember what it does. It moves heat, and one part of it, the Gulf Stream, is why Western Europe stays relatively mild. This isn't just about comfort. This current influences rainfall patterns, storm paths, hurricane strength, monsoons. It affects fishing industries. It affects farming. It affects energy demand in winter. It helps keep climate patterns predictable, and modern civilization depends on predictability. This system works because of two things. Cold water sinks, and salty water sinks even more easily. But Greenland is melting, and melting ice adds fresh water into the North Atlantic. Fresh water is lighter. If enough fresh water accumulates, the surface water may not sink properly. And if it doesn't sink, the entire conveyor belt slows or stops. Has this happened before? Yes. Around 12,000 years ago, during a period called the Younger Dryas, parts of the northern hemisphere cooled rapidly. One leading theory? A massive influx of fresh water disrupted Atlantic circulation. The climate changed fast, not over thousands of years, over decades. Today, measurements suggest this system may already be weaker than it was a century ago. Scientists debate how close we are to a tipping point. Some models say collapse is unlikely this century. Others warn that we may be closer than we think. What's clear is this: the system is sensitive, and Greenland is melting faster every decade. If the current collapsed, the planet would not instantly freeze. Global warming would still continue, but regional changes could be dramatic. Western Europe could experience significant cooling. Rainfall patterns could shift across Africa and South America. The Amazon could become drier. Storm tracks could move. Hurricanes could intensify in some regions. And sea levels along the U.S. East Coast could rise faster than the global average. Because currents help distribute ocean water. When they weaken, water can pile up along coastlines. Now think beyond weather. Think about systems. Agriculture depends on predictable seasons. Energy grids depend on expected winter demand. Cities are built around known climate patterns. If winters become harsher in parts of Europe, energy demand spikes. If rainfall shifts in Africa, crop yields change. If storms intensify, infrastructure costs rise. Climate instability becomes economic instability. And instability is expensive. The biggest risk isn't a Hollywood-style disaster. It's crossing a threshold we don't fully understand. Large systems can appear stable until they suddenly aren't. Once a tipping point is crossed, reversing it may take centuries. The AMOC is part of a network. Ocean currents influence the atmosphere. The atmosphere influences rainfall. Rainfall influences ecosystems. Ecosystems influence carbon storage. Everything connects. So let's go back to the beginning. Europe is warmer than it should be, not because of luck, but because an invisible ocean system moves heat across the Atlantic. That system has been stable for thousands of years. But stability doesn't mean permanence. If it weakens significantly, the effects won't just be about colder winters. They could ripple through agriculture, infrastructure, trade, and global stability. The ocean may look calm from above, but deep below, the balance of climate is constantly in motion. And whether that motion continues as it has, may shape the climate and the economy of the century ahead. If you found this helpful, subscribe. Here on PlanetariHub, we explore the systems that keep our world running, from oceans and energy to infrastructure and global trade. Like the video if you want more deep dives like this. And tell me in the comments, which global system should we break down next? Because the world works in systems, and most of them are invisible.